Hello, myself Dr. BJD Kalyani, working as Associate Professor in the Department of Computer Science and Engineering. In this video, I will discuss the question bank of Module 4 Input-Output Organization and Memory Organization. The first question is, illustrate the characteristic of some common memory technologies. The memory functional unit of the computer mainly employed to store user programs and data. So memory unit is basically the functionality of memory unit is the storage of user programs and data. So while designing the memory, the considerations that can be used are what is the CPU processing speed, and what is the capacity of program and data, the storage capacity, and whether how to design inexpensive and reliable and energy efficient memory. So these design decisions can be considered during the memory construction. And how this memory unit is connected to the CPU. So in the processor, two major registers are used to perform read and write operations on the memory. One is MAR, the second one is MDR. MAR is memory address register. So the address of the memory location can be held in the register MAR. Memory is a continuous allocation of storage cells. Each cell can be identified with the help of the unique address. So, at which location of the memory the operation of read and write can be performed, the address can be stored in the MAR register. The second register is MDR register. The MDR register holds the data to be read or written from the memory. So here to perform two operations are generally implemented on the memory, either read operation or write operation. So at which location this operation can be performed, the address can be held by MAR register, and what data to be read or written, that data can be stored in the MDR register. And how the storage capacity of memory can be defined means based on the address bus and data bus lines. The system bus is a combination of three buses. One is the address bus, data bus, and the control bus. How many lines are there? The address bus lines. If it all k bit of address lines are there, the storage capacity of the memory is 2 power k locations. And in the memory, the basic unit of accessing can be the word. How many number of bits can constitute a word is decided by the number of data bus lines. If it all n bit data bus lines are there, the word length can be same as the n bits. And what operation to be performed on the memory can be directed by the control line. So here the read operation, write operation, memory function complete. These are the control signals that can be transmitted between processor and memory in order to perform, to indicate the read operation, write operation, whether the memory function, the read, write complete can be acknowledged with the help of MSC control signal. So, MAR, MDR two registers, and depending upon the bus, the storage capacity of the memory, and depending upon the control line signals, what operation on the memory to be performed can be decided. So here CPU initiates memory operation by loading the appropriate data into register MDR. So the data can be stored in the MDR register, and the MAR then setting either the read or write control lines. What location can be the address can be loaded by the processor in the MAR, then only the read write operation can be initiated. When the required operation is completed, the memory control circuitry indicates this to the CPU by using the MFC, memory function complete. So it is an acknowledgement that either the read or write operation can be completed. What are the types of memory and what are the various features of each memory can be discussed. So the classification of memory is first categorized into primary memory and secondary memory. The primary memory is connected directly to the CPU. The speed of operation and accessing of the primary memory can be high when compared to the secondary memory. If the built-in memory is not sufficient to hold entire programs and data of the user, to extend this memory capacity, the secondary memory can be employed. So, in the primary memory, again we can have the categories of cache memory and the main memory. So, cache memory is the small high-speed memory that is placed in between CPU and the main memory unit. The frequently accessed data for the computational processing that can be stored in the cache memory to increase the speed of calculations or the processing speed. And the cache memory generally can hold the CPU registers for storage. Main memory is again segregated into RAM and ROM. So RAM is random access memory. Two operations can be supported by the RAM, the read operation as well as the write operation. But RAM is a volatile memory. That means the content of the memory can get erased whenever the power interruption occurs. There are two categories of RAM. One is static RAM, which can be constructed with the electronic element of flip-flop. The second category is the DRAM, dynamic RAM, which is constructed with the electronic element capacitor. So, refreshing of circuit is needed for the DRAM. Next memory is the main memory. The next category of main memory is the ROM. The full form of ROM is read-only memory. That means only one operation, read operation can be permitted in this type of memory. But the ROM is a non-volatile memory. So here the content of the memory can be permanent. So if at all power interruption can also occur. And variety of ROM are PROM, programmable read-only memory, EPROM, erasable programmable read-only memory, EEPROM, electrically erasable programmable read-only memory. And apart from the primary memory, the other classification is secondary memory or auxiliary memory. Various secondary storage devices can be attached to the computer to enhance the storage capacity of the computer. So generally the auxiliary storage devices are magnetic tape, which can permit to access the sequential access. Second one is magnetic disk, which can be either the hard disk or the floppy disk. Third one is optical disk. It is again classified into CD, DVD, BRD, HVD. Next, flash memories, memory card and pen drive. So these are the variety of the memory and what are the characteristics of each type of memory we will discuss. So how these categories of memory can be connected with the CPU. So this is the CPU and two types of memory are primary memory or the main memory, secondary memory or the auxiliary memory. So these are the auxiliary memory devices. So these auxiliary memory devices can connect it to the main memory with the help of IOP, input-output processor. Main memory can be directly connected with the CPU. And to increase the speed of processing, the cache memory can be employed in between the CPU and the main memory. So this is how this memory subsystem can be interfaced with the CPU. Now, what is the primary memory? So due to its direct connection with the CPU, the memory can be generally referred as central memory, primary memory or main memory. The main memory holds the data and the programs that are needed by the CPU. The main memory mainly consists of RAM, which is available in static and dynamic mode. Two varieties of RAM are available. One is static RAM, second one is dynamic RAM. What is RAM? RAM is a volatile in nature, which means the data lost when the device is switched off. And RAM is a primary memory of the computer and it is expensive, and the RAM can be accessed directly. Why? Because it is directly connected to the CPU. RAM is faster memory, therefore it is an internal memory of the computer. Two types of RAM are available. One is SRAM, second one is DRAM. So what are the RAM operations? So N data input lines are provided for the information stored in the memory, so that the word length can be the N data input lines. And K address lines can be connected to the RAM, so that the storage capacity can be the 2 power K. And two control inputs are connected. One is write to perform write operation. Second one is the read operation. And two varieties of RAM are available. One is SRAM, static RAM. So a bit of data stored using the state of the flip-flop. So the major electronic component that can be used for the construction and design of SRAM is the flip-flop. Depending upon the state of flip-flop, the data can be stored in the static RAM. So retains value indefinitely as long as it is keeping up of the power. So that is the volatility in nature. So mostly uses to create cache memory of CPU. Faster and more expensive than the second variety of DRAM, that is the dynamic RAM. So how the storage cell of SRAM can be constructed? So with the help of 6 transistors and the flip-flop can be used to construct the storage cell of the static RAM. The next variety is the dynamic RAM. The dynamic RAM in each cell stores bit with a capacitor and transistor. So the major electronic component in the dynamic RAM is the capacitor, and large storage capacity needs to be refreshed frequently. Why? Because it uses the capacitor as the major electronic component used to create main memory, slower and cheaper than the static RAM. How the DRAM cell can be constructed? With the help of transistors and capacitors, the DRAM cell can be constructed. But it is using the capacitors, so frequent refreshing of the circuit can be required for the DRAM. Now we have to compare what is the features of static RAM and the dynamic RAM. So static RAM can be made up of flip-flop, but whereas the dynamic RAM can be made up of capacitors. Static RAM is large in size, but dynamic RAM is small in size. The data stored in the form of voltage in case of static RAM, but in the form of charge in case of dynamic RAM. Why? Because capacitors are used here. Much expensive as compared to dynamic RAM, the static RAM, but the dynamic RAM is less expensive. Low storage capacity for the static RAM, high storage capacity for the dynamic RAM. The static RAM consumes less power, whereas dynamic RAM consumes more power. Static RAM is fast, dynamic RAM is slow. So the data sustained with time in case of static RAM, but it can lose during the dynamic RAM. Why? Because refreshing circuit can be needed. So these are the various features. Based on various features, the comparison of static RAM and dynamic RAM, which is the two varieties of the main memory or the RAM category. The next variety of the main memory is the ROM. So ROM is used for store programs that are permanently reside in the computer. So here Whenever you switch on the computer, the bootstrap program can be executed, and it can load the operating system into the main memory. But this bootstrap program can be permanently reside in the memory, in the computer. So on the ROM chip, this bootstrap program can be generally stored, and variety of ROMs can be available. ROM is generally used to perform the read operation. If at all you want to perform write operation, some special erasable techniques can be used, either by using the ultraviolet rays or with the help of electric signals. The content of ROM can get erased. So depending upon the variety of ROM or MROM, so mask read-only memory, PROM programmable read-only memory, EEPROM erasable programmable read-only memory, EEPROM electrically erasable programmable read-only memory, Flash EEPROM memory. So these are the varieties of the ROMs available. What is the MROM or the mask ROM? So here connections made by the semiconductor vendors in case of MROM, and it is expensive and several weeks for delivery, high volume only. So bipolar mask technology can be used in the mask ROM. Next variety is PROM, programmable read-only memory. So here one time it can be programmable during manufacturing itself. EEPROM means the program can be erasable and again programmable, but the limited number of erasures are 10 to 100. Next, E-square PROM, electrically erasable ROM. So the erasure can be done with the help of electrical signals. So the number of erasures can be generally 10,000. Next variety is the flash memory. So electrically erasable in the blocks, and the erase cycles can be the 1 lakh cycles can be supported in case of flash memories. So now we have to compare various varieties of ROM memories. So the first main memory is the RAM. It can perform under the category of read-write memory, and it is in place electrically volatile, and write mechanism is electrically done, and the volatile memory is the RAM. But whereas we consider the ROM and the PROM are read-only memories, and erasure is not possible. Only one time is possible in the not possible in the PROM, and the mask can be used for the write mechanism. In case of erasable PROM, E-square PROM, flash memories, they are category of the ROM, but read mostly the memory, and the erasure can be done with the help of special technique. In case of EEPROM, ultraviolet light can be used. In case of E-square PROM, electrical signals, flash memory also electrical signals can be used. So the erasure and writing mechanism can also be supported in case of EEPROM, E-square PROM and flash memory with the help of electricity, and they are ROM is of non-volatile in nature. So these are the features and varieties of various memories of the main memory. And the another category is the auxiliary storage devices. So the storage capacity of main memory is very limited. So to extend this capacity, auxiliary storage devices are connected. And the another name for referring auxiliary memory is the secondary storage. So variety of auxiliary memory devices are there. Magnetic tape, which can support the sequential access, magnetic disk, random access, floppy disk, random access, hard disk and drives, random access. And these are various categories of auxiliary memory devices. So magnetic storage, hard disk, floppy disk and magnetic tape. And the optical storage are CD, DVD, Blu-ray disc. Flash memories are the scan disk and the pen drive. So these are variety of auxiliary memory storage devices. So magnetic tape is a storage medium, which will support only the sequential access, and it support generally the batch processing of data. Magnetic disk can rotate with a very high speed inside the disk drive. So it can support the parallel access. Data are stored on both surface of the disk. So some magnetic material can be used to on both side of the disk. So whenever the read-write head touches the surface of the magnetic disk, it magnetizes and perform the read and write operation. So information is recorded on tracks of the disk surface in the form of tiny magnetic spots. Next variety is the floppy disk. Floppy disk is a removable disk, and portability can be the major concept of the floppy disk. Floppy disks are typically 3.5 inches in diameter. The storage capacity is 1.44 MB of data. Hard disk drive or fixed disk is a data storage device, and it is popularly used as a secondary storage device in the most of the computers, and it uses magnetic storage to store and retrieve digital information using one or more rotating disk. So here magnetic disk drive can have large volumes of storage, and it is a popularly used auxiliary storage device. Next, CD-RAM. CD-RAM is compact disk read-only memory, and it is made of reflective materials. Okay, and here the storage capacity is generally 600 MB of data, and the size is 4.5 inches. Next variety is the optical disk. It is made up of rotating disk which is coated with a thin reflective metal. So by using the pits, the data can be stored on this optical disk. Next variety is flash memories. Flash memory is a volatile form of electronic data storage. As a result, it is used in the many areas where short and medium term data storage is needed. Flash memory technique is visible in many forms. So by using the USB and SD scan disk, the flash memories variety can be available. They are portable in nature. So what is the difference between the primary memory and the secondary memory? The main memory, internal memory are the variety other terms that can be used to refer the primary storage. In case of secondary storage, the external memory or the auxiliary memory are the terms that can be used to refer the secondary storage. Next, data is directly accessed by the processing unit in case of the primary memory. But in order to access the data stored in the secondary memory, first it has to load it to the primary memory, and then only it is available to the CPU. Next, semiconductor chips are used to store the information in primary memory, but magnetic disk, optical disk can be used for the secondary storage devices. Information is stored in temporary, so the volatility can be there in case of primary storage, and in secondary storage they are the permanent, and data operand and stored in a uniform manner in case of primary memory, but it is a random access can be possible in case of secondary storage. Primary memory devices are more expensive when compared to the secondary memory, and primary memory has limited storage capacity, but secondary memory can have a vast storage capacity. So variety of primary memory are RAM and ROM. In case of RAM, dynamic RAM, static RAM. In case of ROM, PROM, EEPROM, EEPROM, all these are the variety of the primary memory. But in case of secondary memory storage devices, magnetic disk, floppy disk, hard disk drives, magnetic tape, all these are variety of secondary storage devices. So with this, we discussed a variety of features of various memory technologies. The next question is, explain asynchronous communication interface with diagram. So here the internal operations of a computer is synchronized with the clock signals. The sequence counter of the control unit can generate these clock pulses. So these clock pulses can be applied to the processor registers and the units, various functional units of the computer that are involved in the data transfer operations. So here, if the resistors and the I/O interfaces share the common clock pulses, then that type of communication is generally referred as synchronous communication. If at all they share the different clock signals, then those units are generally referred as asynchronous communication. So here, what is asynchronous communication interface? So this interface is initialized by the help of control bit loaded into the control register. Then the transmitter register accepts the data byte from the CPU with the data bus. Then transfers shift register for serial transmission. So here, this is the block diagram of the asynchronous communication interface. So here the control register is used to check the control signal. Status register is used to check whether the status of the data transfer, whether it is completed or it is in process. The transmitter register can be used to transmit the data to the shift register to the outside of the computer. And the receiver register can receive the data and can paste in the bus buffer. So chip selection can be done with the CS. Register selection from these four registers. Register selection can be done with the RS. And whether the asynchronous communication interface is performing I/O read or write, depending upon the RD and WR signals can be used. Whenever the data can be transmitted as an output, the read signal can be activated so that the transmitter register and shift register can be involved in the data transfer. Whenever write operation can be, control signal is activated. From the shift register, the receiver register can receive the data and places in the bus buffer. So in this way, the asynchronous communication interface can work. So the truth table of this interface can be, when the chip is selected and WR is there, transmitter register can be active. When the chip and register is on, WR is there, control register can be selected. When the chip selection is 1 and register selection 0, RD is active, receiver register can be active. When both CS and RS are 1, RD is active, status register can be selected. So in this way, the asynchronous communication interface can be worked. Next question, model the different mapping functions in the cache. So cache is a small memory and it is a very high speed memory that can be employed between the CPU and the main memory. So here this is the main memory and this is the CPU. In between the cache memory can be placed. So here from the main memory, the block of data can be transmitted to the cache, and here from the cache to CPU, the word of data can be transmitted. So there is need a mapping function to map the block transfer between main memory to cache and word transfer from cache to CPU. So cache mapping is a technique by which the content of main memory are brought into the cache memory. So cache memory data is transmitted as a block from primary memory to cache memory. So here this block has to be mapped to the word transfer. That process is known as the cache mapping. There are three types of mapping techniques are available. One is associative mapping, second one set associative mapping, third one direct mapping. In case of direct mapping, a particular block of main memory can be mapped only a particular line of cache memory. So the block of the main memory, the partition of the main memory can be considered as each block, and the cache can be partitioned as a line. So each block of main memory can be mapped with the line of the cache. The line number of cache to which a particular block can be mapped is determined with the formula that cache line number by main memory block address modulo number of lines in the cache. So cache line number can be identified at which the block of main memory can be mapped, can be identified with main memory block address modulo number of lines in the cache. So here the mapping register can have three tags. One is the tag, second one is line number. Both can be used to denote the block number, and the line offset or the block offset. So here this is the main memory which can be divided into block 0, 1, j like that until block j plus 2. This main memory block can be mapped to the line of the cache. Here this is the line. Each line is associated with a address tag. So how the line can be identified? The block number, for example, block j has to be mapped to the line of the cache. So j mod the number of lines in the cache is n. So with this the line can be identified so that this block can be mapped directly to the line of the cache. The second method of mapping is associative mapping. A block of main memory can map to any line of the cache that is freely available at that moment. So which line is freely available in the cache? To that the block of the main memory can be mapped in case of associative mapping. This makes fully associative mapping more flexible than the direct mapping. So all the lines of the cache are freely available. Thus any block of main memory can map to any line of the cache. So no need to perform the modulo operation here. So here the physical address register can have the block number or tag, block or line offset. And this is the main memory, and here the freely available line has to be mapped with the memory block. Next is set associative mapping. Set associative mapping combines direct mapping with the fully associative mapping by arranging lines of a cache into sets. So here the tags are to be collected and collaborated as a set in case of set associative mapping. How this set associative mapping can be implemented? So here it is the main memory, the blocks, and here the cache tags can be collected as a set 0, set 1 like that, and these tags can have the cache line numbers. So here physical address mapping can require three tags: the tag number, index and the offset. The word offset is used to identify which word of the block we want to access. And set number is used to identify which block in the main memory is mapped to the which set of the cache. So here the block of the main memory can be mapped to the set of the cache. So in that particular set, which line can be decided with the help of tag. Tag is used to uniquely identify each block in a set. So comparison of three mapping techniques. In the direct mapping, it is a simple technique and maps each block of main memory to one possible cache line. But in case of associative mapping, permit any block of main memory to any line of the cache which is freely available. The cache control logic interprets memory address simply as a tag and word field. So in associative mapping, to determine whether a block is in the cache control logic must simultaneously examine. In case of set associative mapping, a compromise that exhibits that the strength of both the direct and associative mapping can be applied. So these are the list of references used in this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.